Okay, welcome. This is the lecture for section 4.3. I will be posting this online. I will also attempt to post it on Canvas, as well as it will be uploaded to YouTube. Okay, so today we're doing solving systems of linear equations by the addition method. Last class we did substitution. This class we're going to do addition method, sometimes also referred to as elimination, because we eliminate a variable by adding the equations together. All right, so practice changing equations into standard form. It is necessary for this to be the equations to be in standard form if you're going to add them together. That's just the way it works. Okay, there we go. So 5y minus this is in standard form. Notice that the x term is first, then the y term. That's the problem. Okay, so standard form, we've got to flip so that x is first. That's all it is. Now remember, when it's a subtraction, that makes it a negative when we move it up front. Okay, on this next one, we've got to subtract the y to the other side. So we end up with 4x minus y equals 1. For number 3 here, we want no fractions. So what we're going to do is multiply everything by 10. And that's going to get rid of that denominator there, the 1/10. But when I do that, I'm going to get 10x minus y. Because 1/10 times 10 is 1. And then 10 times 10 for my constant, so that becomes 100. So that is now in standard form. Okay. Sorry, I'm drawing lines all over it because I need to shift it, and I'm still remembering how to use this program. Okay. Now, this one is, number 4 here is in standard form, kind of. It has the fraction, so we have to get rid of those. So I'm going to multiply the whole thing by 5. And that's going to get rid of the 5 denominator. So I now am going to have 5 times 1/8 is 8. Whoops. Over 8 x plus 3y equals 19 times 5. So that's going to be 100 minus 5, which is 95. Okay, now I have to get rid of the 8. So once again, I'm going to 2x plus 3y equals 9. When I multiply the lower by -2, I have -2x minus 2y equals -6. Add these together. These disappear. I end up with y equals, because 3 minus 2 is 1. Y equals 9 minus 6 is 3, so y is 3. Woohoo! Okay, we got that one. Now we plug that in to get my x value. So I have 2x plus 3 times 3, which is 9, equals 9. Interesting. So if I subtract 9, I have 2x equals 0. So that means x has to equal 0. Okay, that kind of thing comes out a little too neat for my taste. We'll check this to make sure we're right. Okay, since I did the 2x plus 3y to find the 0, I'm going to plug it into the other one. X plus y, 0 plus 3 equals 3. Yeah, that's true. So this does indeed solve both of these equations. Okay, number 3 here. It's much easier for me to write a little closer to the screen. Okay. All right. Okay, I can just add these straight up because I have a plus y and a minus y. That makes life easy. Those cancel out. 1x plus 2x is 3x. 5 minus 11 is -6. Divide by 3. X is -2. Yay. Find y. X, whoops. All right, sorry about that. Okay. -2. Why am I doing that? I don't know why I was suddenly making it shift. All right, -2. See, it's -2 plus y equals 5. So I add 2 to both sides. I get y equals 7. So my solution should be -2, 7. Now, real quick, I'm going to check that, though, in the other equation. So 2x becomes -4 minus y, which is 7, equals -11. Does -4 plus a -7 equal -11? Yes, it does. Okay, so that's good. Let's move on to our next equation. Why is that staying there? Hang on, I'm going to pause. Okay, moving on to the next problem. All right, x plus 2y, x plus 3y. So the best thing to do is just turn one of those x's into a negative. So I'm going to rewrite the equation. I have x plus 2y equals 5. And I'm going to take my entire equation, multiply by -1, -x minus 3y equals sorry. Then I'm going to add these together. Now that I've multiplied through by the negative, the x's will eliminate. 2 minus 3 is a -1, so I have a -1y equals 5 minus 7 is -2. Multiply through by -1 in order to eliminate the negative, and I have y equals 2. I'm going to plug that into x plus 2y equals 5. Well, this is a 4, so I'm going to subtract 4 from both sides. Now I have x equals 1. Okay, sorry about that. It just automatically flipped to the next page. Okay, so my point that is my solution is 1, 2. Okay, but now I'm going to check it real quick. So I apologize. I have 2x plus 3y equals 7. I'm going to plug this x and y in. 1 plus 3 times 2 is 6 equals 7. Does 1 plus 6 equal 7? Yes, it does. So this does solve both equations. All right, let's go on to the next problem. Okay, 3x plus 2y equals 10. 2x plus 5y equals 3. Okay, so none of these will easily work. So what I'm going to have to do is I'm going to multiply them by 2 and by 1 by 2 and the other one by 3. The reason I'm choosing 2 and 3 and not 2 and 5 is 5 is a bigger number. So it just makes bigger numbers. And I like the smaller numbers, are easier to handle. So I'm going to use the 2 and the 3. So I'm going to eliminate my x's. So I'm going to multiply the top equation by 2 and the bottom equation by a negative 3. So I have opposite signs so that they will be able to add and disappear. Okay, so this is going to times 2 gives me 6x plus 4y equals 20. Times negative 3 gives me negative 6x minus 15y equals negative 9. Now, I add the two equations. The x's disappear. I have 4 minus 15 gives me a negative 11y. 20 minus 9 is 11. I divide by negative 11. Y equals negative 1. Plug that into either one of my equations. I'll do the top. 3x minus 2. That's 2 times negative 1 equals 10. I add the 2. 3x equals 12. I divide by 3. X equals 4. Okay, so my answer is negative 1, 4. But I'm going to check it real quick in the bottom equation. Negative 2, that's the 2x, plus 5 times 4 is 20, equals 3. That doesn't work. Maybe we have a no solution. I don't see how we have a no solution. Okay, let's try see what we did wrong. Negative 15, 20, negative 9, 6 and negative 6. 4 and negative 15 is negative 11. Yeah, and 11 gives me negative 1. 3x, that negative 1 was y, so 3x minus 2 equals 10. Add 2, you get 12. Divide by 3, you get 4. X is 4. That's my problem. I wrote it in the... I wrote my answer backwards. See? That's why we check. All right, let's try this one more time. All right, so our answer is 4. Negative 1. You all are probably yelling at your computer screen telling me what I did wrong, but that's okay. All right, so now we check. 2 times 4 is 8, plus 5 times negative 1 is a negative 5, equals 3. Sure enough, 8 minus 5 is 3. Yay, so that worked. See, I caught my own error because I checked. If you don't check, you don't catch your own errors. All right. Oh, that's right. We're on point. Okay, hang on. X. I hit it the next slide. Okay, I get the fun of attempting to get this to be bigger. Okay, let's go back. We do this. Come on, there we are. Come on. All right. 4x minus 8 equals 3y, and x equal... Okay, first off, we're going to have to get this bottom equation into the proper order. Oh, the top one is also. All right, so 4x... Subtract the 3y over. I add the 8 to the other side. Okay, so we did a minus 3y to get it here and a plus 8 to get that one over there. So now we have 3y minus, 4x minus 3y equals 8. All right, now we have to do the same thing with the next one. X, I have to add the 2y equals, the 13 is in the right place. Okay. So now I have x, y, and then the constant on the other side of the equal sign. Yay, this is the right form. All right, now what do? I could multiply top by 2 and bottom by 3 and get rid of the y. I could multiply the bottom by negative 4. Well, I like that better. I only have to do one set of multiplication. So I'm going to have 4x minus 3y equals 8. And then I'm going to take this one and multiply by negative 4. Now, that's going to make me a nasty constant at the end, but that's all right. Negative 4x minus 8y equals, well, that's 4 times 10 is 40, 4 times 3 is 12, 40 and 12 is 52. So I have a negative 52. I add them together. These go away. I have negative 3 and negative 8 gives me a negative 11. Negative 52 and a positive 8 give me negative 44. Yay, that's good because, oops, negative 11y, negative 44. I like that because it's a multiple of 11. The 44 is. Divide by a negative 11. Those disappear. I've got y equals 4. Positive 4. Yay. All right, now we go find x. I'm going to go back to my x equal equation to find x because that will make my life the easiest. So x is equal to 13 minus 2 times y. Y is 4. 13 minus 8 is 5. So x is 5. So my answer is going to be 5, 4. I'm checking to make sure I got the x and the y in the right place. All right, but let's just do a quick double check on the other equation. 4 times my x is 4 times 5. That's 20. Minus 8, does that equal 3 times my y, which is 4. 3 times 4 is 12. 20 minus 8 equals 12. This is true. Okay, we got our answer. Yay. All right, now we're going to check the next one. Okay, 2x minus 6y. There we go. Okay. And a 3x equals. This is a problem. I need it on the other side of the y there. So I've got 2x minus 6y equals 5. And 3x, I have to subtract the 9y to get it to the other side. All right, now I've got them all in order. Okay, I can multiply by 3 and then by 2 to get rid of the x's. But the y's, what do I have to do? I'm still going to have to multiply by 3 and 2 to get the y's to be 18s so they cancel. So let's try this. Okay, so what happens when I multiply the first one by 3? I get 6x minus 18y equals 5. Multiply the second equation by a negative 2. I get a negative 6x plus 18y equals negative 4. Well, we're going to have a problem with this. They both disappear. I end up with 0 equals 1. Okay, there may be new math, but I don't think so. That doesn't ever work. Remember when we come up with a solution that is never, ever, ever, ever true. two constants that are not equal set equal to each other. Never true. This means no solution. They are parallel. So they don't ever cross. There is no solution of these two linear equations. All right, we're moving on to 8. All right, 2/3 x plus 1/6 y. Nasty. We got to get these in standard form. First thing, we're going to get rid of all of the denominators on my first equation. Notice 6 will do the trick, because 6 will get rid of the 3's as well as the 6. So I'm going to take this whole thing and multiply by 6. So that's going to give me, well, when I multiply the 6 times 2/3, the 3's crossed out, but that's going to leave me a 2 out of that 6. So I would have 4. So this is going to be 4x. When I multiply it tied to the 1/6, that just becomes a 1, so I have y. Now when I multiply it by the 2/3, I have the same thing that happened with the 4, because again it's 2/3. I'm going to end up with 4. All right, yay, no fractions. Life is so much better. Okay, now the second one, notice I don't have in standard form either. I'm going to have to move the y by subtracting it. So I have 3x minus y equals 12. Well, notice my y's will cancel right now, so I'm going to do that first. Goodbye, y's. 3x plus 4x is 7x, and that's equal to 12 plus 4, which is 16. Well, that's not pretty. X is going to equal 16 sevenths. Okay, I'm going to double check my math just to be sure I'm correct, because that's not a pretty answer. Sometimes we get not pretty answers, so that's okay. It makes me a little nervous, so I go check. And I don't see I did anything wrong. So we're going to just keep going with this. Okay, 16 sevenths for x. Oh, plugging that in is not going to be pretty. Okay, so 3 times 16 sevenths equals 12 plus y. Well, 3 times 16 sevenths. 3 times 16 is 48. So I have 48 over 7 equals 12 plus y. I got to subtract the 12. All right, the only way I can do this is common denominator, so that 12 needs to be over a 7. So the numerator becomes 12 times 7. 12 times 7 is 84. Okay. 48 minus 84. Okay, minus 50 would be 34. And add 2, 36. So I've got 36 over 7 equals y. That's just not pretty. Okay, so that means my answer is 16 over 7, comma 36 over 7. All right, we are definitely going to check that one out. Okay, so we used this one to find our point. So it's obviously going to satisfy that because we did the math for it. So we're going to check it in the one with all the fractions. No, that's just awful. Okay. 2/3 times 16 sevenths plus 1/6 times 36 sevenths equals 2/3. Okay. Now, this 6, thankfully, crosses off with the 36, turning this into a 6 up here. So I actually have 6 sevenths. But I need the 3, don't I? I do. Because I have 21 right here, so I'm going to need the 3. Okay, I think instead of crossing out the 6, because I need the... I need the 3. I've got 21 here, so I'm going to cross out the 2 and leave a 3 behind, and that leaves me with an 18. So now I have 18 over 21, and I have 2 times 16 is 32 plus 18. All of this over 21. So 32 plus 18 is 42 is 50. Okay, that's not working either. All right, I'm going to pause it. I'm going to go figure out what I did wrong, and I'll be right back. For you, it's going to seem like instantaneous. Okay, I'm back. Now, I think my problem was that, this was supposed to be a negative. It's supposed to be a negative 36/7. So if I do that, then I end up with, let me get rid of this. This 18, come on. Really? You're going to do that to me? Apparently it is. All right. It's going to take me a while to get rid of the, okay, that's close enough. Okay, so this is going to become a minus right here. 32 minus 18 is 14. That's what I wanted. So what I actually have is 14 over 21. Both divisible by 7, leaving 2/3. So that's my answer. But see, it helped me find my mistake. So my answer is negative 36 over 7 for my y value. Okay, so this then is my complete and accurate answer with the negative. All right, now we're going to move on to 9. And it looks like that's going to be the end of it. Okay. All right, so let's do number 9. 7x plus 12y. And we're going to get rid of our fraction by multiplying through by 2. So I have 7x plus 12y equals 4. I notice when I multiply the 2 times the 6, I'm going to get 12. So I'm going to do a negative 2, okay? Negative 2. So in this case, negative 2 would give me a negative 7x, minus 12y, these are all going to disappear, equals negative 4. That one disappears. This means we have an infinite solutions. They were actually the same line. If I had not done the negative, I would have ended up with 7x plus 12y equals 4, and you'd see exactly they were the exact same line. So 0, 0, my answer is infinite solutions. Same line. Okay. There we go. And we're done. So I will get this all uploaded.